Good morning, friends. In the previous section of my presentation, we have seen the introduction of CNC machine, and in this section we are particularly going to see about CNC part programming, which is a major paper of 4th semester BE Mechanical Engineering student affiliated to the Anna University colleges. In this CNC programming, part programming, it can be written in many methods. First one is a manual part programming, which is being written with the help of G codes and M codes. Second one is a computer assisted part programming, which is being written with the help of APT language. Third one is a part programming using CAD/CAM software. In this section, we are particularly going to discuss about part programming using APT language, that is computer assisted part programming. In computer assisted part programming, the machining instructions are written in English-like statements that are subsequently translated by the computer into the low-level machine code that can be interpreted and executed by the machine tool controller. When using one of the part programming language, the two main tasks of the programmer are defining the geometry of the work part. Second one is to specify the tool path and operation sequence. In computer assisted part programming, the viewpoint of the programmer is that the workpiece remains stationary and the tool is instructed to move relative to the part. To complete the program, speed and feed must be specified, tool must be called, and tolerance must be given for circular interpolation. For writing the APT language, APT statement, there are four basic types of statement. First one is a geometry statement, second one is a motion statement, third one is a post-processor statement, fourth one is an auxiliary statement. Geometry statement is also called definition statement, that is used to define the geometry element. Second one is a motion command, that is used to specify the tool path. Third one is a post-processor statement, that is used to control the machine tool operation, for example to specify the speed, feed, tolerance, etc. Fourth one is an auxiliary statement. It is also called miscellaneous statement, that is used to name the part program, insert commands in the program, accomplish similar functions. Most APT statement includes a slash as part of the punctuation. APT vocabulary words that immediately precedes the slash are called major words, whereas those that follow the slash are called minor words. For writing the geometry statement, this is the command we have to follow. Symbol is equal to, what is the geometry type? Slash descriptive type. For example, how to write P1, it is represented in symbol P1 is equal to, what is the geometry type? It is a point slash descriptive 20, 40, 60. 20 represent x-axis, 40 represent y-axis, 60 represents z-axis, and each and every words are separated with the help of commas. Similarly, it can be written in the P2 can be written in this particular aspect also. P2 is equal to point slash intersection of L1 and L2. Okay. Next, how to, in the same geometry statement, how to define a line. L3 is equal to line slash P3 comma P4. Similarly, it can also be written in this particular pattern. L4 is equal to line slash P5 parallel to L3. Similarly, for defining the circle geometry, C1 is equal to circle slash center of P1 of radius 25. It can be. Similarly, C2 is equal to circle slash P4 comma P5 comma P6. Similarly, for plane, it can also be defined like this. Next, rules for formulating APT geometry statement. Coordinate data must be specified in the order X, then Y, then Z. Any symbol used as a descriptive data must have been previously defined. A symbol can be used to define only one geometry element. Only one symbol can be used to define any given element. For example, for this particular geometry, we are going to see how to write, or for this machining operation, we are going to see how to write the part programming. Okay, so this is 0 comma 0, this is 160 comma 0, this is 160 comma 90, this point is 35 comma 90, and this is 70 comma 30, 70 comma 60, 130 comma 60, 120 comma 30. All the points, coordinate points are being mentioned, and we are going to define all the points. This is a point P1, this is a point P2, point P3, P4, and L1 is in between the P1 intersection of P1 and P2, and L2 line is in between intersection of P2 and P3. Similarly, L3 is in between P3 point and P4, intersection of P3 and P4, and L4 is the intersection of point P4 and P1. This P5, P6, P7, P8, all the geometry has been specified, and C1 everything. So point has been specified, line has been specified, and circle has been specified in this particular milling operations. Okay. First we will see how to write the part programming using the geometrical statement. P1 is equal to point slash 0 comma 0 comma 0. It means point P1 is a geometry point, and the x-axis it is in 0 location, y-axis it is 0 location, and in z-axis it is in 0. And P2 point it is in 160 in x-axis, in y-axis it is at 0, and in z-axis it is in 0. Similarly, P3, P4, P5, P6, P7, P8, all the points has been defined. First the point has been defined. Next the line, all the lines has been defined. Third one, our circle has been defined, and L3, L4, all the geometry statement has been written. Next we will see how to write the motion commands. Motion command slash descriptive. This is the basic formula to write. For example, go to slash P1. It means that go to the point P1 from the place where it is, from that particular location, go to the P1 where the tool has to go. From that it indicates that. Similarly, from the target point, the way it has to define, the motion command has to be written, and this pattern also it can be written. From the target point you can go to the x-axis minus 20, y-axis minus 20, and z-axis you can go to the 0. This is the way also it can be written. Similarly, go to DLTA slash 50 comma 120 comma 40. DLTA means it is an incremental move. From that particular point, incremental move you have to go to the x-axis 50, y-axis 120, and z-axis 40. So DLTA command specify the incremental move for the tool. Okay, the way it has to be instructed. Similarly, for writing a point-to-point motion, this can be go to point P2. Go to incremental move of 0 comma 0 comma in z-axis minus 50. So it can also be written in this particular pattern. For contouring motion command, the tool position must be continuously controlled throughout the move. The tool is directed along two intersecting surfaces until it reaches the third surface, as shown in the figure in the next slide. These three surfaces are specified name in APT. They are: first one is the dry surface, second one is the pot surface, third one is the check surface. Now we will see what is a dry surface. The surface guides the side of the cutter, that is called dry surface. The surface on which bottom or nose of the tool is guided, that is called part surface. Next, third one is this is a surface that stops the forward motion of the tool in the execution of the current movement. One might say that the surface check the advance of the tool. In this diagram you can see that the tool bottom surface, that particular part we call it as a pod surface, and the side of the cutter we call that as a drive surface, and the end we call it is called as a check surface to the end point where the tool has to move. Okay, so now it can there are several ways in which check surface can be used. This is determined by using any of the 4 APT modified words in the descriptive data of the motion statement. The 4 modifier words are to, on, past and tangent to. Okay, the tool can go to till that checkpoint it can go, that is go to that to the checkpoint. Next, on the checkpoint it can. Third one is past the checkpoint. The tool has to go past of the checkpoint. Tangent to, the tool has to move tangent to the circle. It has to be, these are the 4 modifier commands in the motion commands. Okay. In writing a motion statement, the pod programmer must keep in mind the direction in which the tool is coming in the preceding motion. The programmer must pretend to be riding on the top of the tool as a driving a car. After the tool reaches a check surface in the preceding move, does the next move involve a right turn or left turn or what? The answer to this question is determined by one of the following 6 motion words whose interruptions are illustrated in the following figure. The tool can either move up or it can move down, it can move forward, or the tool has to move backward direction, or the tool has to go in leftward direction, or the tool has to go in the rightward direction. So this is a basic command. It has been motion command. Go to left, go to right, go forward, go back, go up and go upward. So to begin the sequence of motion command, the from statement is used from where it has to go to the target point. Okay, and go /to means it is the tool has to go near to the check post. This 2 represents go to near the check post. 2 PL1 plane 1 2 plane 2 next to plane 3. Okay, this first it has to go to the plane 1, second it has to go to the plane 2, third it has to go to the plane 3. This is the way it has to be from the target point it has to. So this has been represented in the diagram. Next, the go /to is not the same as the go to command. Go to is used to only represent point to point motion. The go / command is used initialize a sequence of contouring motion and may take alternative forms as go on, go /on, go /to or go /past. Okay, so that go to statement is different and this go /to statement is different. This is not the same. For point to point you use go to. For the tool has to move to the checkpoint, that situation we use go /to. Okay, go /to or go /on or go /past. This is the way we write the motion commands. Okay, go to this represent go to the right / plane 3 past PL4 plane 4. Okay, this way also it can be written. Note that PL2 is not mentioned in the new command. PL3, which was a check surface in the preceding command, is now the drive surface in the new command. And the new check surface is PL4. Although the pod surface may remain the same throughout the motion sequence, the drive surface and check surface must be redefined in each new contouring motion commands. The planes around the pod outline can be replaced by lines and the APT commands can be replaced by the following: from /p target, go /to L1 to plane 2 to L3, like this. Also go to right L3 past L4. This is the way the motion commands can be written. And this milling operation geometry we have seen. For this now we are going to see how to write the part programming for this milling operations. Okay. So this way by which we are going to write the program. Okay. For example, APT contouring motion from P target go slash to the L1 to the plane 2 on L4. Okay, so from the target point go to the go near to L1, then from that to the plane 2 you have to go, then from on behind the check post it has to go, behind the L4 it has to go. Similarly, go right, go left, go forward, and the program has been written for the milling operation similarly. And let us see what is a post processor and auxiliary statement. Post processor statement controls the operation of the machine tool and play a supporting role in generating the tool path. Such statements are used to define cutter size, specify speed and feed, turn coolant flow on, off, and control other features of particular machine tool on which machining job will be performed. Okay, next we will see what is an post processor statement. Post processor statement is used to define the part programming, specify which post processor are used, insert remarks into the program, and so on. Auxiliary statement have no effect on the generation of tool path. Example, it specify the part number, remarks, finish, all those end of the program, all those things it indicates. This is an auxiliary statement. Now let us see how to write the part programming for this milling operation. For example, we are doing a drilling operation. Drill tool diameter must be 7 mm. Cutter number 1 we use for drilling operation. The speed 1000 rpm and the tool rotates in clockwise direction, and feed is 0.05 mm per minute. Similarly, for milling operation we use N mill cutting tool of diameter 20 mm. Tool cutter number 2 is used here. Speed is 1000 rpm in clockwise direction. Feed 50 mm per minute. The target point starting point is 0, minus 50, 10. It is a thing, and the program has written as we have seen here. We have used an part number auxiliary statement. Unit has been specified in mm. Cutter size is 20. From the target point it has to go 0, minus 50, and so on. We have seen all those things how to write in the previous slide itself. For doing milling operation, all those, first the point has to be specified, then the line has to be specified, then the circle geometry statement has to be specified, then plane has to be specified, and then the motion command has been given here. That's load the tool number, cutter tool, spindle 1000 rpm, it has to rotate in clockwise. What is the feed, coolant is on, all those commands has been used here for writing the end milling operation. All these commands has been discussed in the previous slide itself. Okay, and this is a command has been used for writing the part programming for doing and drilling operation. The same geometry statement, the same motion command has been used here. That is from the rapid go to P target, spindle is off, coolant off, load the tool number 1, rapid, the tool has to go rapidly, it has to move fast, go to slash point number 5, coolant flat, coolant has to be on to spindle has to rotate. So this is what this is the way by which the program has to be written. And finally you have to say that go to the P target. After doing all the operation, the tool has to go back to the target point, spindle has to be off, coolant has to be off, and the program has been finished. It has been defined in the end of the program. Okay, Thank you for your patient listening. If you have got any clarification, you can contact me through my email IDs. Any queries, you can contact me mail ID. Okay. Thank you. Thanks a lot.